number 2. Welcome. I am Mr. Meeker and going to go over case study number 2 with you. So a little bit of information as we get started here. With case study number 2, it's on Huntington's disease. Huntington's disease is a rare autosomal dominant disease that results in the slow deterioration of mental abilities. It's estimated about 300,000 Americans have this, and more are likely to develop, or at least at risk of developing it. Symptoms appear at the ages of 30 to 50 and worsen over a 10-year period, and it is fatal. You will usually die from this or complications of this. Every person who inherits the HD allele will eventually develop the disease, and it does have an interesting genetic aspect in that it doesn't manifest itself until later on in life, after a person has often already had children and therefore often passed on the allele before they even know they have it. You can, however, take genetic tests to see if you're at risk for a disease. All right, so let's look at this pedigree. So over here we have a situation where this person who does not have Huntington's is going to show the homozygous recessive genotype. Now, this is a little different from the last case study where the homozygous recessive did show the disease we're looking at. But because we're looking at a dominant disease, when the circle is filled in, we know that they have a big H. And then in this case, we also know that this female has a little h because she has children that don't have the Huntington's disease, so we know that she must have passed on the little h. Okay. All right, so that leads us over here to person number 1. Sorry, I covered up the numeral 1 there with my h's, but the mom to start here has a big H and a little h. Person number 2, right? So we can look at this from sort of the opposite perspective. From the offspring perspective, we know that they have Huntington's, so they must have got that H from mom, that big H from mom. But we also know that they had a dad that does not carry Huntington's or does not have Huntington's, so must have passed on the little h. So we know that person number 2 is also heterozygous, big H, little h. And then finally, person number 3, not having Huntington's at all, their genotype is easy because we know they can only carry the recessive, only have the recessive. So they are little h, little h. All right, so to answer the questions, is it dominant or recessive? Well, I mean, obviously the paragraph up top said it's dominant, but really we want to look at the context clues. So what evidence do we have for that? And there was a really key part in the reading where it says every person who inherits the HD allele will develop the disease. In other words, it can't be masked. Okay, so we know it's a dominant trait just because of that. Further on, if we look at the pedigree, we notice that it doesn't skip generations. Every person who has it had a parent who has it. Every person who has it had a parent who has it. So the fact that it can't skip generations means that it's not recessive. And then the last thing to help us out is that we also know that it's not X-linked because it's found in both males and females in seemingly even percentages there. All right, so let's do a practice Punnett square with this information. Person 3 has a child with someone who does not have Huntington's. We know from up above that person 3 is homozygous recessive. So we put a little h above for person number 3. And then we know that they're having a child with somebody who does not have the disease. So it's also little h, all little h's in the box. There is a 0% chance that they have a child with Huntington's. For something a little bit more, one more thing here. So that's verification that, again, you can't have children that have it without a parent that has it, because one of the parents would have to have a big H in order for a child to have Huntington's. So 2 parents that don't have Huntington's will have no chance of having a child with Huntington's. Just for an extra little practice here, what if individual 2 had another child? So in that case, individual 2 was the heterozygous with homozygous recessive. So if we set up that Punnett square here, again, we would have a big H and a little h, that's person number 2, and then cross with a little h, So in this case, we see that there's a 50% chance that the individual 2 passes on the big H, 50% chance that they pass on the little h. Their partner always passes on the little h. And so again, we see a 50-50 shot that their next child would have Huntington's. All right, I hope that helps. If you have any questions, please see your teacher, and we'll be back with case study number 3 in just a minute.